All right, so we are going to take a look at the following question. This is car on a ramp with friction, and we are using the new textbook, Nelson Physics. Okay, so now the question is, a car is making a turn on a dry banked highway ramp, is experiencing friction. The coefficient of static friction between the tires and the road is 0.60. Now remember what we said was the tires are, of course, centrifugal force is pushing it outward, and the mu s, or the static friction, is putting it inward. Okay, so the mu s, or I should say the fs, is one of the components that's opposing my centrifugal force. Now I said one of the components, and the reason being because this is on a banked highway. Okay, so we're going to erase that. All right, next it says determine the maximum speed of the car at which the car can safely negotiate a turn of radius. So my radius is 200 meters, and my angle is 20 degrees. So again, car on a ramp, 200 meters, 20 degrees. Okay. Now in this situation, as we said, there is friction that is involved, and so I'm going to try to make this as clear as possible. There's your car with your tires. Yes, yes. Okay. And Fn. Okay, bear with me. Fg. And we said Fnx and Fny. Fnx, Fny. Now there is one more component here. Now this static friction, as I said, is like so. Static friction is on the road. It's not in the air. Right? Like this. Centrifugal force is pushing my car outward like this. Centrifugal force is pushing it outward. So static friction is opposing my centrifugal force. And so my Fs is pointed downward like this. Fs. If it's pointed downward, that means I have an Fsx component and an Fsy component. So as I said, this is going to get ugly pretty quickly, and it has. Okay, so you've got two components right there. That one, and right here. Okay, as you could see. All right, so now when we are taking a look at solving it, we're going to solve it in the following situation. Just like the last one, we said F net y equals to 0. I know in the y direction my car is not floating in the air. So the acceleration in the y direction is 0. Now what are my forces that are in the y direction? Well, look at them. I have this, and I have this. 3 forces. So I have to look at that. That's why the FBD is so important. You mess up on the FBD, you mess up on the question. So I'm going to say Fny, which is going up, minus Fsy, which is going down, minus Fg, which is going down, which equals to 0. There is my system's equation. So far so good. Does this make sense? Okay. Now right here Fny. Now you know Fny is going to be Fn cos of 20 minus Fsy is going to be Fs sine of 20. Okay. Minus mg. So there's one thing that kind of helps us. This angle right here is 20 degrees. This angle right here is also 20 degrees. This angle right here is also 20 degrees. So that is helpful because it helps us in making this much simpler than it is. Now we don't know what Fs is. We have to figure it out. Okay? So Fn cos 20 minus Fs sine 20 minus mg, which equals to 0. Now we're going to solve for Fn. So what we're going to do is Fn, which equals to mg brings over to the other side, mg, plus Fs sine of 20 divided by cos of 20. Okay. Now what the textbook has done is they've taken it one extra step, so maybe I'm going to go back and do that. Just don't copy that, okay? Just hold. Don't copy this yet. Don't copy, just don't copy it. So what they've done is as follows. They said Fn cos 20. I think it might be better to do that. Minus. Now we know that what is Fs? That's correct. So Fs is Fs mu s times Fn, which equals to Fs. Okay? So that's what they did right here. They subbed that in. They said mu s times Fn times sine 20 minus mg, which equals to 0. I think this might be better to do. Okay? So now we're going to solve for Fn. So what we're going to do is bring this over to the other side, and then so you get Fn cos 20 minus mu s. You see where I'm going to go with this. Sine 20, which equals to mg. Now I'm going to take out Fn. Because I have Fn here, I've got Fn here. Does that make sense? So I'm going to factor out Fn, and you're left with cos 20 minus mu s sine 20, which equals to mg. Does that make sense? You see what we did? So you got Fn, which equals to mg divided by cos 20 minus mu s sine 20. So far so good. Now this is just the first portion of it. So I'll probably have to erase and rewrite it, the f net y section. This is just the f net y. We have to do the x now. So far so good. As you could see, this is going to get, yeah, not pretty at all. Okay. So let's bring this down slightly. Can I erase some of this? Yes? Yeah, don't use that one. This is the more correct version. So I'll leave this equation right here. I'll erase the rest of it. Okay. All right. Now we're going to do the f net x, which equals to mv squared over r. Okay. Now in the x direction, I've got a few different forces. I've got Fnx, which is going this way, as you could see it, right? But I also have Fsx going this way. See, Fnx going towards the west, and Fsx also going towards the west, which equals to mv squared over r. Does that make sense? Fnx and Fsx. Okay, what is Fnx? Well, Fnx is Fn sine of 20 plus, what is Fs? Fs is mu s times Fn cos of 20, which equals to mv squared over r. So far so good? Okay. Now I'm going to do exactly the same thing. I'm going to take out the Fn, so Fn sine of 20 plus mu s cos of 20, which equals to mv squared over r. Okay. Now we want to solve for your velocity. We want to solve for the velocity. So we're going to bring the r up. We're going to divide it by the m. Keep this formula right here. We're going to erase it right now. We'll bring it back again in a few minutes. Okay. So you're going to end up with Fn times r, okay, times sine of 20 plus mu s cos of 20, okay, divided by m, and then square root the whole thing. As you could see, it's not looking pretty at all, which equals to v. Does that make sense? Fn times r, sine of 20 plus mu s cos of 20 divided by m. Okay, now what we're going to do next is we are going to sub the first equation that I came up with into the Fn. So that equation that we had was Fn, which equals to mg divided by cos theta minus mu s sine theta. We're going to sub that into here. I know it's not looking pretty at all. So you end up with the following. God. So mg divided by cos 20 minus mu s sine 20. Okay? Times r times sine of 20 plus mu s cos 20 divided by m. Yeah? It is. This whole thing is divided by m. But I just don't have space. But believe it or not, the m and m will cancel out, so it doesn't really matter actually. So the m and m will cancel out. Okay? This, we're trying to find velocity. I mean, this says right here, v equals to. Yes. The r is right here. Right, it is the same thing. Okay? Alright, so let's go back up and erase a few things. Can I erase this top part? Yeah. Okay. And let's erase this too right here. And let's move that up. So when we rewrite it, this is what it's going to look like. It's going to be v equals to the square root of, okay, it's going to be gr times sine 20 plus mu s cos 20 divided by cos 20 minus mu s sine 20. Okay, so what we did was m and m cancel out. So I've got this over that. And that g right here multiplied by r. This is basically what we did. We've simplified it. Now we can plug in our values. So g, 9.8 times 200. Okay. Sine of 20. What is sine of 20? Can somebody do that for me, please? So 0.342 plus mu s, of course, was 0.60. So cos 20 times 0.60. 0.564. Now I'm taking your word for it that this is correct. Okay, what's cos 20 by itself? Minus 0.60 times sine 20. .205. Okay, so now of course you're going to add those two together and subtract those two. Okay, we have less than 1 minute to finish this. So you get v equals to 9.8 times 200. Okay, what do you get for the top part right here? And what do you get for the bottom part? Yeah. 49.15. That's correct. So 49 meters per second. And this is, yes, if you solve for it, that's what you're going to get. Are we good?